Okay, so we're going to talk about an introduction to Azure Event Hubs. And so the goal is to just give you a high-level overview of what Event Hubs are, how they work, all that kind of stuff. Sorry, let's trying to. My monitors are giving me just the tiniest bit of trouble. 1 second. The problem with working on my laptop is sometimes it thinks that I still have my laptop screen. Okay, so real quick about me. I work as a business intelligence consultant. I work as a Pluralsight author, and I'm a Microsoft MVP. And so I'm really always honored when I can give back to the community. And this is one of those ways to do that. If you have particular questions about any of this stuff, please feel free to email me at the email address below. I'm on Twitter, I'm on LinkedIn, and I'm always happy to help. And I do want to say that streaming data is an area that I'm still getting more involved in, right? So my day job is very heavily around um, Power BI and reporting and that sort of thing. But I think data engineering is going to become more and more important. And that's one of the reasons why I've taken an interest in Azure Event Hubs. So what are we going to talk about? Well, a couple different things. The first question is, what is Azure Event Hubs? Because I don't think that you could easily intuit or guess what it does just based on the name. For me, when I was learning about it, I had assumed that this was some very developer specific kind of tool. And from actually looking at it and understanding what it does, it has a much broader range of applications than I would have first thought. We're going to talk a bit about how it works or how you use it. We'll talk about a few details with implementation. And then we've got just kind of the simplest bare bones kind of demo of, we'll show you how to create an event hub, how to write events to it, and how to read events. Nothing particularly fancy there. So what is Azure Event Hubs? Well, if we look at the Microsoft documentation, they say that Azure Event Hubs is a scalable event processing service. Well, what does that mean, right? And there's three pieces that I want to pull out of that. So the first is scalable. So it is both horizontally scalable and vertically scalable in the sense that it's distributed. So whenever you're working with Azure Event Hubs, you're going to have a number of partitions that are totally separate. So you can have separate event producers adding events to those partitions. You can have separate consumers reading at the same time, all this kind of stuff. And so this allows you to scale out in a kind of horizontal fashion. You can also increase the number of throughput units. So on demand, you can say, you know what, it's Black Friday. We've got twice as many events happening, twice as many transactions, what have you. I need more throughput. And so you can scale it like any other dial on Azure. Event processing simply means that it receives and stores events. And we'll talk about what an event is because, again, the general definition as far as event hubs are concerned is broader than what you might think of when you think of an event, right? When someone says event, I think about like a birthday party or something like that. And then finally, service, as in platform as a service. And so what that means is that it's a managed backend. You don't have to deal with any of that. You're not running any servers. You're not managing anything. And so it functions a lot like many of the other services on Azure, for good or for bad. You may have people who prefer to use Kafka and prefer to manage it themselves, feeling they can get better performance or better control or what have you. And there's a lot of trade-offs that we won't get into exactly here. But those are kind of the things I want to pull out from the Microsoft definition, out of the Microsoft definition. So the next question is, what is an event? Well, so the first thing is it's something that happened in the past. And you might say, Eugene, most things have happened in the past. A few things will happen in the future, but most things happen in the past. But what I mean in particular is that is a record of something, right? So normally when you think this, you're thinking about logs, you're thinking about notifications, what have you. And so something in opposition to that might be what you in programming might call a command, right? Where it's basically, here's something that needs to be done. But the whole point with an event is not only has it something happen, the event information cannot be changed. right? So the way to think about that is maybe you think about accounting, and you can void something. You can go in later and say, this has been voided, but you're not supposed to just go in and delete stuff, right? Or you might think about an old-fashioned newspaper, where, back in the day, it's this printed thing. You can't change it, or you're not supposed to. No one's going to go in with a marker and update every newspaper that's wrong. So you issue a retraction, right? And so these are the two big things that makes an event an event. And there's a lot of stuff that fits under this definition if we think in those terms. So a lot of traditional transactions don't necessarily fit, at least the way that we think of them, because a lot of times we might make changes to data in a transactional database. And another thing that comes out of this is that there's no assumed thing to do, right? You can have a number of subscribers to an event hub that are going to read it, but it's not like something like Power Automate or what have you, where maybe I expect it to send an email when a certain type of event occurs. There's no expectation result. It's just stuff that happens. Events are also very small. So usually we're talking about 1 to 2 kilobytes, right? So think size of an email, right? With Azure Event Hubs, you can go up to a megabyte, but you're probably missing the point if your events are a megabyte. Just like how you can send 10 megabyte emails, but you're probably also missing the point of an email. These are supposed to be small. And then finally, the contents are arbitrary. Azure Event Hubs does not care at all about what you put in your event. As far as it's concerned, you're just sending it a big old bucket of bits. And what's in there is it's a black box as far as Azure Event Hubs is concerned. Now, there is some functionality that's in preview called schema registry, and that's just a way of storing the schema of the data that you're sending, right? So that the producers and consumers can kind of be on the same page and can maybe have faster processing. But I want you to think of Azure Event Hubs much more like just a contents blind infrastructure, right? So it's like if you're the United States Postal Service and you're sending these boxes and you're not looking at what's inside. It's not like postcards where you can just read it, okay? So what problems does Azure Event Hubs solve? Presumably, we're interested in Azure Event Hubs because it solves a problem. When you look at the number of services on Azure, you might think that maybe some of the engineers are just making products for its own sake. But I promise you, Azure Event Hub solves a specific set of problems. In particular, there's 3 that come to mind. So first is the speed of data ingestion. And I'm not a huge fan of this term because it makes me think of digestion or indigestion, but it's the term that we have. And specifically, it's the speed of receiving the data. And the whole idea is that whenever you start thinking about sensors, when you start thinking about mobile applications, when you start thinking about doing things at scale, then even just getting the data is a big deal. And sometimes the part of just receiving the data and the part of dealing with it and processing it or storing it become much more separated. So if you're used to working with relational databases, then there may not be much of a distinction between data ingestion and data processing and data storage because it all happens, in milliseconds. But again, whenever you're scaling out, that may not be as easy. And so Event Hubs is a way to store the data temporarily as it's coming in. You might think of it, if we're thinking about these packages, a lot of businesses back in like the 1950s and stuff would have mail rooms, right? And so you can kind of think of it like that. Another thing it helps with is the speed of data processing. And in this particular case, I'm not talking about complex analytics or anything like that, but just that we need to do something with the data as fast as possible. So one of the things that I think about is whenever I travel somewhere, I like to let the bank know that I'm going to be traveling. Pardon me. I like to let the bank know that I'm going to be traveling, because if I don't, they might send me fraud alerts. There was one time I was traveling and somebody in South America was trying to buy a laptop with my business card, and they called me right away and they checked, and I got a text message and all this kind of stuff. And so you can think about situations where you want to have low latency between when the data is received and when it's processed. Now, the important thing here is Azure Event Hubs does not do any data processing whatsoever. It is just it's roads. It's the UPS, it's whatever. It doesn't care about the contents of your events. It's not doing anything in particular with them. It's just somewhere to drop the information and have other programs and applications read it and do something as quickly as possible. But it is designed to have very low latency. The third thing, and this is something that applies to event processing architectures in general, is decoupling reads and writes. And so if you've ever had to do an application migration, you can understand why you might want to do this, right? You may want to decouple them in terms of the network space, because I've had to do software upgrades where we moved a piece of software from one SQL server to another, and we had to update every single user machine to change the connection string. Or even worse, I've had to do SharePoint migrations to a different SQL server. And at least back in the day, I don't know if it's changed, SharePoint doesn't like it when you change the name of the SQL server. So what you have to do is you have to actually, thankfully I've forgotten the name of the tool, but there's a SQL tool where you can basically change, so to speak, the DNS of the SQL server and do this kind of redirect for the naming. And so you can imagine that situation, but you can also imagine a situation where you want to make your environment more robust, make it easier to spin up applications or containers or what have you. And so you don't want to have the writes happen at the same time as the data is processed. You might want to be able to write the data as soon as it comes in and have some stuff that processes it immediately and have some stuff that maybe processes it a day later. And so because Azure Event Hubs operates as this storage area, and because the producers of the events and the consumers of the events have no understanding of each other, then you can separate both in terms of space and time. And so the way to think about Azure Event Hubs is that it is a temporary home for your data. And I do mean temporary. Data that is put into Azure Event Hubs will only last for 1 to 7 days at the most, and then it's deleted. Now, there are solutions for long-term storage, and we'll talk about that, but I really want to emphasize that this is not a data lake. This is not a relational database. This is just, the bus station for your data. It's going somewhere else eventually, or it's going in the trash. And for a lot of this data, that's fine. We want to be responsive, but we don't need to keep a record of everything forever. So what problems does it not solve? I think there's a tendency to want to sell a piece of technology as the end all be all. But one of the things that I've learned about data solutions when it comes to Azure is that they are much more specialized and targeted than what you may be used to with a regular relational database. So what does it not solve? So the first one that we already mentioned is long-term storage. So for this, you're going to use the data capture functionality. And so you're going to save your data either to blob storage or a variant of blob storage, which is data lake storage. It also doesn't solve streaming analytics. Again, there's no particular way to look at the data that's in Azure Event Hubs. Now you can use Azure Stream Analytics and hook them up and it works beautifully, but you're going to need another tool. And then finally, as part of that, there is no support for ad hoc querying, right? There is no world where you get to write SQL or some other querying language and just pull out arbitrary pieces of information. It is a linear flow of data. It is a queue of data. And so again, you can use Azure Stream Analytics and do some analysis that way, but there's no way to just peer into the contents of Azure Event Hubs. You're going to have to be writing code or using a separate tool. So what is inside of Azure Event Hubs? So let's talk about just the general organization of it. So the first thing you're going to have is you're going to have an Azure resource group. And then outside of that, but the slide was too small, is an Azure subscription, right? But you have an Azure resource group. And inside of that, you're going to create an Event Hub namespace. So the namespace is interesting because it's mostly a container, right? It is, the namespace part is you're going to get a URL that has to be unique across Azure. And that's how you're going to talk to your Event Hubs. Sorry, I apologize for all the yawning, everyone. I just got back from Utah, so it's been a bit of a time zone shift for me. You're also going to manage the scalability and pricing tiers with the Azure Event Hub namespace. So think of it as a name, an endpoint, and some settings. Inside of that, you're going to have a number of event hubs, as many as you want. And these are the things that you actually talk to. These are the things that store your data and so on. Then outside of that event hub, you're going to have producers and you're going to have consumers. And these could be anything that uses the libraries. A producer could be code that you've written. It could be something with Power Automate. It could be something with Logic Apps. It could be something with Event Grid. Consumer, again, bunch of options. Could be something that you wrote, could be Azure Stream Analytics, could be Power Automate, again, all these sorts of things. And then within the Event Hub, you've got partitions and offsets. So an Event Hub can have 1 to 32 partitions. Those are determined at time of creation, which means if you get it wrong, you can't undo it. And then inside of each partition, all the events have an offset. They have both a numerical offset. So in terms of, you know, I don't know if anyone still goes to the deli, but you would get those little tickets and wait in line. So it's your number in line. And then events also have a byte offset, which is basically how far in terms of the size of the data. So how does it work? So there's a couple different steps. So first is the producer side. So the producer creates an event and then they serialize it. So what does it mean to serialize? Well, right now I am serializing the thoughts in my head into words that you can understand, right? And I could say these words in a bunch of different order or a bunch of different possible orders, but I have to pick one. I have to pick one word that's going to come after another and then another in a serial fashion. And so the same thing applies to your events, because if you're working with code, there's a good chance you might be dealing with object-oriented programming. And objects aren't inherently serializable, that's a word, because they're hierarchical data structures, right? You have to figure out not only, okay, how are we going to flatten this out into a linear set of bytes, but also how are we going to encode it? So in the example with Python, we're using UTF-8 because that's the default text encoding, but you could do it a bunch of different ways. If you're using the schema registry, you could use something like Avro or what have you. Then you're going to create a batch of events. So the whole idea is that it's not particularly efficient to send one event at a time, although you can. But instead, you might want to create a batch of 100 events and then send them all to a namespace endpoint. So that's the producer side. And then the events are received and they're assigned to a partition and they're given offset numbers within that partition. Oh, hold on one moment. Slight technical issue. Okay. My computer is trying to tell me that I should quit work and I have it set to shut down at 6 p.m. So had a bit of a countdown moment there. All right, so the events are assigned a partition, they're given an offset number, and then later, at any point later, as long as it's before the event is deleted, a consumer can request events based on a partition and an offset. And what that means is that the consumer can read events out of order if it wanted to, right? It could read the first 10 events and then change the offset and read them again. It also means that you can scale out your consumption by having a different program process for each of the partitions. And then finally, the data is either stored long-term or it is removed via the retention policy. And again, that's usually 1 to 7 days, depending on your settings and your payment tier. So another way to think of an Event Hub is as a distributed commit log. So there's 2 ways that you might have run into commit logs. So the first one is if you've ever used SQL Server and you've ever had to restore from a log backup, right? Because SQL Server has the same issue in that, okay, maybe the data has this structure, but when we make changes, we have to serialize it to disk. We have to save it to disk. And we want to be able to restore to a specific point in time. So it needs to be a log of things that have been committed to the database. Azure Event Hubs is very similar. Each event represents an item in the log, a point in time in the log, but it's distributed. And what that means is that it's using partitions so that there's no guarantee that your events are going to be in a specific order across all partitions. But instead, within a certain partition, there's a guarantee of an ordering, right? And so that's one way to think of it. Another way is to think of it like GitHub or Git, where that is distributed amongst many computers and it's a commit log. You make some changes, you type git -m because you should be leaving commit messages for everything, and then commit, right? Similar ideas that it's this chain of commits, only in terms of Azure Event Hubs, each commit is a single event. Let's talk a little bit more about some of the details of actually implementing this. So the first thing we need to talk about is pricing tiers. There are 3 levels, I think maybe 4, depending on how you count, of pricing for Azure Event Hub. So the first one is basic, and basic is, well, I want to play around with this, right? I mean, that's just anytime you're dealing with Azure, that's what it tends to be. Is okay, I want to explore this technology, or I'm using it for a very simple project, and so you get 1 day of retention. That's it, and you're paying 1.5 cents per hour per throughput unit. So throughput units, those can go anywhere, if I remember, from 1 to 20. And they're, your arbitrary Azure Monopoly money units, but I believe 1 throughput unit corresponds to, I want to say, 1,000 messages or 1 megabyte per second, whichever is lower, of ingress of data going in, and then twice that for data going out. Next, you have standard, which gives you up to 7 days of retention, costs twice as much, and it gives you Kafka support. So you can take any of your producers or consumers that have support for Kafka, and you can use that with Azure Event Hubs. And you have to look at the documentation. You're not going to get every single feature that Kafka has, but for basic reading and writing of events, it works great. You get support for data capture. So again, 7 days is only so much. We want to save this data in some data lake where it's just going to fill up and fill up and fill up, and then maybe we'll do some analytics on it. You get data capture for that, and then you get 20 consumer groups. So a consumer group, the way to think of that is it's kind of like an application ID for your consumers. And so the whole idea is that you could have multiple containers or multiple processes or what have you, all using the same consumer group so that they can do processing in parallel. Because if you're using basic and you have multiple programs trying to read from the Event Hub, they're going to be fighting for that data because you're using the same consumer group. So consumer group is a logical program or application ID that can be used by multiple physical consumers in order to scale out horizontally. And then finally, you've got premium and dedicated, which are 2, it gets a little bit confusing, but they're 2 different tiers. But it's one of those things that if you have to ask how much it costs, it's too expensive, right? But you can get 90 days of retention. It costs $7 per hour per compute unit, which is basically, think similar to cores or virtual machines or that sort of thing. But basically, if you're using so much Azure Event Hubs that you need more, then you can essentially pay Microsoft to run a dedicated virtual machine just for your Azure Event Hubs. That's what's going on there. Some input options. So usually by default, you're going to be writing custom code, but there's integrations with things like Azure Monitor. There's a connector for the Power Platform, so Power Automate, Logic Apps, Power Apps. And there's Azure Event Grid, which is designed to have a bunch of connectors and can actually both read and write to Azure Event Hubs. If you're writing custom code, you're probably going to want to use .NET Core. Anything by Microsoft or Microsoft is going to have the best support, but there's support for Java, there's support for Python, there's support for JavaScript and Go. In terms of protocols and how you're going to talk with it, the default is the Advanced Message Queuing Protocol, or AMQP. This is, from my understanding, pretty standard when it comes to the industry, in terms of, okay, when we're dealing with event hubs, service buses, message queues, all those sorts of things, this is pretty common. There's support for Kafka if you're paying for standard. And then finally, there's technically HTTP support. I should actually check if that's HTTPS, but you get the idea. Now, what if I want to scale this out? So there's 4 ways that you can scale it. So the first is you can use more producers, right? You can have tons and tons of different programs producing events. You can increase the throughput units, which, as I said before, is basically a measure of bandwidth, is the way to think of that over time. It's, just how much data can you shove in there at any given point in time. And again, somewhere in the documentation, they say it explicitly, but I'm pretty sure it corresponds to either 1,000 messages per second or a megabyte per second or what have you. And I want to say that you can go up to 20 throughput units, or if you need more, pay for the dedicated tier. You can also have a larger number of partitions. And this is going to give you better scalability, primarily whenever you're reading from Azure Event Hubs, because you can have a separate consumer for every partition. By default, if you're using the libraries, it'll auto balance. And so you can have one consumer reading from all your partitions and all these sorts of things. But you could go up to 32. The big thing is you want to have some idea of this ahead of time, because like I said, you cannot change the number of partitions on an Event Hub. Once it's set, which is one area where it's not as great as Kafka. In terms of output, the default is going to be Azure Blob Storage. You can also output the Data Lake Generation 1, but there's Generation 2, so I wouldn't recommend that. One of the things that I found out that kind of shocked me was Azure Data Lake Gen 2 storage is literally blob storage with a checkbox. And the checkbox, I mean, I don't want to be dismissive of the technical feat here. This is a big deal that they were able to make it so that you could use blob storage for these data lake functionality. But I thought they were separate products, right? And with Gen 1, it was. But with Gen 2, you're just clicking a checkbox called hierarchical namespaces, which is a really fancy term for real folders. Because normally when you're dealing with Azure Blob Storage, it will fake the folder structure. And what I mean by that is each object, each file or what have you that's on Blob Storage has a file location, file folder structure associated with it, but it isn't real. And so what that means is if you try to rename a folder, you have to scan through and update all of those files, right? There's no file format, file system like we're used to. And so this wasn't ideal for data lake work because there's a lot of things that will do a bunch of processing of a bunch of files and then rename the folder and say, okay, now it's done. So Azure Data Lake Generation 2 storage is blob storage with a little checkbox. You've got built-in support for Azure Stream Analytics, works really, really well. And then you could use something like Azure Databricks or just Databricks in general, what have you, because there's a Spark library. Now, when you're doing the long-term output of the data, it's being saved as Avro. So Avro is a somewhat binary, somewhat compressed data format. But the whole idea is that it provides a schema like the one you see here, and then it has the data. And so I personally think of it as kind of like if we decided that we wanted JSON data, but we wanted to compress it, right? The important thing that I want you to see here is, let's see if I can actually highlight it, but we'll go with a general green. Down here, there's the body of your event. And what it is just an array of bytes. That's all the structure it is. That's all the structure it demands. And then the rest of this is metadata. We can see that we've got a sequence number. We can see that we've got an offset, right? And so we have the information about where this is in the Event Hub and all those sorts of things. But Azure Event Hubs doesn't care about the contents of your data. Now, what if you care about the contents of your data? Well, there's schema registry, which is, last I saw it was still in preview, and it's basically a place to store your Avro schemas so that your event producers and event consumers can use the same exact structure for your data. Although in the demo, we're just writing plain text. You could do whatever. But also you're going to get better performance on the consumer side because it has that schema and it can cache it and all that sort of stuff. Okay, so I've got some really simple demos. Does anyone have any questions at this point?
Yes, there is one question.
Okay.
What is the difference truly between the old style service bus, message bus queue, and the new Azure DevOps Event Hub thing? Or is there a difference?
Yeah, no, that's a great question. So, hold on, let me, before I forget. Oh, why is it gonna? Before I forget, don't forget at the end to give us feedback. So the Azure Event Hubs and Service Bus both operate in very similar spaces. In fact, when we look at the connection strings, we're going to see that it's .servicebus.azure.com, right? Whenever we look at the protocols, I believe they both use AMQP. The difference is in terms of expectations and feature sets, but it's it's like deciding do you want a Jeep or do you want a sedan, right? They'll both will get you there, but they're meant for different purposes. The difference is Service Bus is primarily concerned about reliability, because the whole idea, at least to my understanding, and again, I'm more of a report guy, but my understanding is Service Bus it's a lot more in that kind of command space than event space. It's a lot more of like, hey, this needs processed by something specific down the road, right? This needs to be taken care of. So you can imagine, again, you're trying to decouple your enterprise architecture, but you still want to make sure that the email gets sent when something happens, right? And so Service Bus will have something like a dead letter queue. It'll in case there's an error with your messengers and processed or what have you, it has much more fail safes in place to handle things. I believe that message or event sizes in Service Bus can be much, much larger. I don't remember off the top of my head, but I remember it being substantial. Whereas Event Hubs, there is no expectation that anybody's going to ever read your events. There's that song like, message in a bottle, you just throw it into the ocean, you hope somebody reads it. Events are very, very small, like I said, so 1 to 2 kilobytes. And so the big way of thinking about it is that Event Hubs is optimizing for speed and is optimizing for scalability, and Service Bus is optimizing for reliability and consistency and fail-safe kind of capability. So that's the way that I think about it. But they operate in very similar spaces. They are two similar tools. So that's a great question. Okay, so let's go ahead and hop into a demo. I will get rid of those ing annotations. Okay, so first, let's take a look at what's involved. Actually, let me see if I can change my screen so I'm not constantly looking off to the left. Perfect. Okay, so back to this. So let's take a look at what's involved with creating an event hub, how you manage it. And I've got some super simple demo code that's basically modified from the documentation on how to create and receive events. Again, I've I've dabbled in C# before and these sorts of things, but I know just enough to be dangerous when it comes to that. I'm used to DAX and SQL and all these things. So here we are in the Azure portal. And so what we can do is we can create a resource. And so if we look for event hubs, what you'll notice is that there's two options that come up. There's event hubs and the event hubs cluster, right? And so the event hubs cluster is, this is whenever you're paying for basically a virtual machine, right? It's this dedicated tier, and it's not what you're usually going to want. Again, it's very expensive. I want to say it's like $5,000 per month when you do the math. I forget, but we saw it was like $8 an hour per CU. So instead, what we want is we just want event hubs. And so Azure Event Hubs. And so here we can go ahead and create a resource group. So we can call this future data driven. And here is the namespace. And like, relating back to that previous question, you can see servicebus.windows.net, right? So clearly they're building off of an existing infrastructure to support event hubs. So you can tell there's a lot of similarities there, but I could call this future data driven. Hopefully someone else isn't using this name to make a demo. And I can pick my pricing tier. And this is done at the namespace level, like I said. So we could do premium. We'll just do basic, right? And so I can go all the way to 40 throughput units. But we'll just say 1. It's going to do some validation. And then we'll create our event hub. And these generally deploy pretty quickly in my experience, although I may regret saying that out loud whenever I'm doing a demo. So, it's thinking about it. While that's baking, we'll go ahead and show you how to actually write to it. So what I've done is I've already created an event hub called Eugene's Event Hubs, or event hub namespace. And within it, I've got an event hub called main hub. And so what I want to do is I want to write to that. And so what I can do is I've taken some really, really simple Python code here. And I'm creating an Event Hub producer client. So we can see that Microsoft has created a library that we're importing, and we're specifically importing this class. And this will do a lot of the work for us. And we have to give it a connection string, and we have to tell it what Event Hub we're talking to, which might be part of the connection string. And so what you can do for that is there are these shared access policies. So you can create a manage policy, a listen policy. And so as a result of that, you get this connection string that you can then use. This is how you talk to the event hubs. And so what I can do is I can go ahead and run this, and I'm creating a random number to pretend that I've got a temperature reading from some random sensor. And here I'm creating some JSON, but you could put whatever you want there, right? You could put Avro, total gibberish, whatever, it doesn't matter. because Azure Event Hubs does not care about the contents. And then it's just going to keep running this forever, and it's just going to sleep for like a quarter of a second, make a new event, sleep, all that kind of stuff. So if I go ahead and run that, you can see that it's creating these fake temperature readings. So then I can go to my receive event code, which is very similar. And what it's doing is we're creating a checkpoint store. So we're using Azure Blob Storage to store, okay, where are we in the Event Hub? Because if I shut this, if I start receiving the events and I stop and I want to start again, I need to remember where I was during that point. And then we're going to use the Event Hub consumer client, which is also provided by Microsoft. And we're going to connect to it, and we're going to create and we're going to receive an event. We're going to tell it, okay, let's start at the beginning. And whenever we receive the event, run the onEvent function we've created, do it asynchronously because we don't know when we're going to receive it. And we're just going to output the string value. And we're using an encoding of UTF-8 because that's the default text encoding for Python. And we have to specify that because we don't know, in terms of this program, what encoding has been used, because Event Hubs can't tell us. It doesn't know either. So let's see, Python receive event. So takes a second and then starts from the beginning. And now you can see it's pretty much in sync. As soon as we create an event, we're reading an event, right? And so that's kind of the simple portion of how it works. And so if we go back to overview, we can see that the it's going to take a second, but we can see that we're starting to get this spike in events received. And so I'll let it run for a little bit, but you'll see we'll get a similar spike. We can also see that I've set it up so that this data is being captured to Azure Blob Storage, and you have control over the way that that namespace is being written out. And something you want to think about with that is that when you're dealing with things like data lakes, you want to make sure that you store this information in a way that allows you to do kind of data pruning, query pruning, whatever the technical term is. Because if you do it by year, month, day, for example, that makes it really easy to filter to a specific month of data, right? So you want to give some thought to the data capture piece. So let's go to our future data driven. Here we can go ahead and create a, oh, no, that's not what I wanted to do. Oh, this is the resource group. That's why I'm getting confused. My apologies. This is the problem with naming them the same thing. Go to resource. Okay, so here we can go ahead and create an event hub. We can call it FTD test. We can give it up to 32 partitions. And we could say, okay, I want to retain this for 7 days. I want to be able to capture data, but we made it in the basic tier. And so right now we can't do that. So we can go ahead and create our FTD test. We can have shared access policies, both at the namespace level, so we get access to all the event hubs within that namespace. Or we can go to our event hub and we can manage that there. So no policy has been set up. We can create one just for listening. That's not how you spell that. And again, we could tell it, okay, we want to capture the data. We could have it go out to Azure Stream Analytics like we see here and run queries based off of that. And let's see, we can control consumer group. So consumer group is, again, we're in basics, so we can't do it in this example, but we can go back to the other one. We can see that we've got the spike of all the events we're creating and receiving. And so then we can create a consumer group, and we can call this test group. And so again, if we go back to the code, we can see here that we're using the default consumer group for our receiving events piece, right? But you can imagine a situation where you want to have a different application that doesn't interfere with this. Okay, so I think that's the bulk of what I wanted to cover. I can touch on some other things, but okay, looks like we do have a couple questions. So let's see, Okay, so events along with producers and consumers sound a lot like, we already talked about that. So Gina has a question. The namespace has to be unique throughout Azure rather than throughout the tenant. My understanding is yes, it has to be unique throughout the entire, throughout all of Azure, because it's essentially a URL as far as I understand it, right? So here I've got Eugene Event Hubs .servicebus.windows.net. And because HTTP is one of the ways that you talk to the Event Hub, that means that the URL has to be unique. So yeah, as far as I'm aware, it has to be unique across all of Azure. I haven't tested it where, you know, I haven't tried like doing one region, another region, but let's just see real quick if it gives us a useful error message or something like that. But yeah, my understanding is it has to be unique across all of Azure, which means you have to get a little creative with the naming sometimes. Yeah, exactly. That's why I put Eugene, because it's an old man name, and you know nobody uses that. So let's see. Tests. I'm sure somebody else has used it. Yeah. Okay. So it doesn't give us a particularly useful details, but I mean, it's basically URL, so I'm pretty sure that's the case. Oh yeah, my first event hub, my second event hub. Okay, so Adriano confirms that it is a public address exposed to the internet. I appreciate that. Does anyone else have any other? That's funny. Does anyone else have any other questions on any of this stuff? We've got a whole 10 minutes, so I'm happy to answer questions. Or even if there's no other questions with Azure Event Hubs, if you got some question about Power BI or the stuff that I do, I'm more than happy to talk about that as well.
Doesn't look as if,
yeah, we got some.
Just as you're about to say something.
Yeah. No, I appreciate Gina helping me out, right? The whole like virtual presentation thing is a nightmare, because like in face to face you can read the room and be like, oh yeah, okay, everyone's done, or and then like you have to. I'm getting better at the art of having like 15 minutes of extra content in my back pocket if no one has any questions. So what use cases do I see for Event Hubs in terms of data consumption? Yeah, so that's interesting. So you can do stream analytics off of it, right? And then you could feed that into Power BI. I found that user story to be a bit lackluster, because at least the last time that I looked, and it's probably been a year, but you couldn't really do a lot of integration between that streaming data set and the rest of the report in Power BI, right? And I'm sure there are some cases where people need like super down to the second data, but for the work that I do, I'm working with businesses, and usually it's reporting on transactional systems and all that kind of stuff. What is interesting though is I did a course on Kafka streams and what they call KSQL. And learning about Kafka really opened up my eyes, because when you start thinking about some of these things, you start thinking about almost inverting the database. And so what I mean by that is, when you look at Kafka and how people are using Kafka streams and KSQL and how you could be using Azure Event Hubs, they're treating these event processing stores as kind of the source of truth for a lot of their data. And it allows them to do some interesting things because the data is immutable, right? So you don't have to worry so much about conflicts or all those sorts of things. And so I find the idea of like event-driven architectures to be really, really interesting, because it allows you to handle scale both in terms of volumes, but just in terms of organizational scale in much more interesting ways. Now, it's hard to do this with Azure Event Hubs because you only store 7 days worth of data, where on the Kafka side, you can do it for much longer. You could do a dedicated tier and store it up for 90. The other big use case that I see is less less reporting and more program integration, in the sense of like you think about a company like New Relic or some other company that they help you kind of wire up your programs and report on errors, or maybe you're running a website and you want to do user click analysis or all these kinds of things. Event Hubs, like I said, makes sense as this temporary home, right? It helps you store the data quickly. You can respond to it if you need to, but what is really cool is that then you can move that data into a data lake and then do these long-term analyses, right? So a use case that I think makes a lot of sense is if you have some application, whether that's a e-commerce website or a user application or something that's throwing off a lot of this data. I think Azure Event Hubs can be a reasonable kind of part in between. But honestly, my expectation is that there's not going to be a lot of direct reporting off of Azure Event Hubs. Instead, I see a lot more of either systems that need to be able to respond to the data quickly. So you think about like fraud detection. You use that credit card and you want to be able to respond as quickly as possible. So things that need low latency, that makes a lot of sense to me. Or things where, okay, we're going to take this data and then we're going to store it long-term into Azure Data Lake in that compressed Avro format, and then we're going to do analysis and reporting on it. Because I've played around with Azure Stream Analytics, and it's cool what you can do with it, but it's very niche. It's very specialized, because it's like running a group by on a stream of data, right? That's really the extent of it. There's other stuff you can do, but that's kind of the use case. And if that's your use case, if you want to catch anomalies or something where like you've got values that are way out of the norm or shifting, that's great. Like this is going to sound silly, but I'm a type 1 diabetic, and so I'm intentionally interested in streaming data because I produce a lot of it, right? So my blood sugar is actually high. I shouldn't have this on recording, but that's okay. But you can see it would have been great if Stream Analytics told me that my blood sugar was high right before I gave this presentation. I must be nervous. So great question. Okay, we've got another 5 minutes. If we finish 5 minutes early, that's fine by me. Does anyone have any other questions? Oh, thank you. I appreciate the feedback, Sonar. I took a long break during the past year, and so it's nice to be getting back into this. Let's see. Yeah, so Adriano has a good point that you're going to be using something on top, and generally, that you're looking at Kafka, Stream Analytics, or Azure Databricks or Spark, because it allows you to aggregate the data, and that's absolutely right. I mean, you look at Azure Event Hubs, you can't do anything with it by itself, but then you're going to be using tools that people are used to. I mentioned a little bit earlier, you can use Databricks, Azure Databricks, and Microsoft. They do have a demo on doing that, and it's basically you're using the Spark library to read from Azure Event Hubs. I appreciate the help, Adriano. Like I said, I consider myself an expert on Power BI. I consider myself somebody who's still learning when it comes to this streaming data kind of stuff. Okay. If we don't have any other questions, we